This is Euclid Book 4, Proposition 13, Part 4. Now what we have done here is we have drawn 5 new lines. We have FK here, FL here, FH here, FG here, and FM here. Okay? And we have drawn all 5 of these lines perpendicular to lines. Okay? So FK is perpendicular to CD, FL is perpendicular to DE, FM is perpendicular to AE, FG is perpendicular to AB, and FH is perpendicular to BC. So far, so good. Now, long ago in this proof, we established that BCF and DCF are exactly the same size. We covered that in Part 3. Well, all we're doing is we're taking out the BH part of this length. So now we can go on to say that HCF, which is actually BCF, okay, HCF is the same size as KCF because DCF and KCF are the exact same angle. You see that? DCF is the same angle as KCF. We just chopped off the DK part of it. Alright, so this angle is equal in size to this angle. Because these 2 lines here were drawn perpendicular to these 2 lines respectively, okay, in other words, FK was drawn perpendicular to CD and FH was drawn perpendicular to BC, we can then say that FKC, this angle right here, is equal in size to CHF, because these are both right angles. And then we can go on to say that this line right here, FC, is equal to itself. Now, by Euclid Book 1, Proposition 26, that makes this triangle here, FCK, equal to this triangle here, FCH. These 2 triangles are exactly the same size. And then we can go all the way around this pentagon and say that triangle FHB and FHB and FBG are the same size, and we can go on to say that FBG and FAG are the same size, and we can go all the way around the pentagon and do that. Okay, we're not going to do that. Anyway, by doing that, we can then go on to say that the length of FK and the length of FH are exactly the same size. These 2 lines are exactly the same size. FK is equal to FH, FH is equal to FG, FG is equal to FM, and FM is equal to FL, and FL is equal to FK. And if you guys really want me to go through this entire proof, I'll happily do it, but I'll tell you what, I think that you guys have pretty much got it by now. Anyway, by having all those lines equal in length, okay, so if we were to take our compass, which apparently I lost my pencil here, but if we were to take our compass, and I'll get the pencil in there in a little bit, and we were to draw all the way around, and we were to use like length FK as the radius of a circle, we were to draw all this around, we would, in essence, hang on just a second here, we would circumscribe, okay, if we were to use FK as the length here, we would circumscribe a circle around this pentagon. Oh, I'm sorry, not circumscribe, we would inscribe it. I'm sorry, we would inscribe it. We wouldn't circumscribe, we would inscribe it. And that's what we were trying to do in the first place. We were trying to draw a circle inside the pentagon here, and this circle would pass through FK and FL and FM and FG and FH. We would actually inscribe a circle, a perfectly round circle inside this pentagon. But Euclid was not done. No, sir, he couldn't make it that simple. Nope. Okay. And I will tell you more in the next video, so stay tuned.